In this video, we will write a C language program for binary search tree. In this program, I will show you how to insert an element in a binary search tree, how to perform search, and also we will see how to perform in-order traversal that already we have seen same in-order traversal will perform. Let us give the project name as BST, that is binary search tree, and the language is C language. Yeah, project is ready. I'll clear off all the comments. Here, first of all, I should define a structure for binary search tree, structure for a node of a binary search tree. So I will say struct node, and inside this I need three members, that is left child, data, integer type data I am taking, and struct node right child. Then here globally I will declare a root, that is pointer of type node, and I will also initialize it as null. So initially nothing is there in binary search tree. Now let us write a function for insert. Void insert. I will take the key value that has to be inserted. Now already root is globally accessible, so I will directly access this root here. Inside this insert function, I may require some temporary variable. So the first variable that I will take, that is node t, that will point upon root. Then also I will take a node pointer, that is r, that will be following t, and also I will create one more pointer, that is p, that is used for creating a new node. Using this p, I will create a new node. Now in this function, first of all, I will check whether root is null. If root is null, then this is the first node. So simply I have to create a new node and make it as a root node. So by using pointer p, I will create a new node. For creating a new node, call malloc function. So for that, first of all, typecast node star, then malloc function, and here size of struct node. Then p's data, I will set it as key value that I want to insert, and p's left child as well as p's right child, I will assign them as null. So this has to be done when root is null, means this is the very first node. Otherwise, we will run the procedure what we have seen on whiteboard. So on whiteboard, we have seen that while t is not equal to null, we will continue searching for a key value, and r will be following t. And here we write on the procedure same as searching, that if key is less than t's data, then move t upon left child, else if key is greater than t's data, then move t upon right child, else key element is found. So if key element is found, we are not going to insert anything, simply we will return, means we will stop the procedure. Now once we have came out of the while loop, so t will become null and r will be pointing on some location where we have to insert a new node. So for that, first of all, I will create a new node. So p assign new node. So already we have written this code for creating a new node. I will copy that portion and paste it here. So it's the same code for creating a new node. Now once the new node is created, now I should link it with a binary search tree. So I have to again check using r if key is less than r's data, means the new node should come on the left hand side. So directly I will write on here r's l child should be assigned with the p, that is new node, else r's right child should be assigned with that new node p. That's it. This is how a new node will be inserted in a binary search tree. So the code is a little lengthy. This is the portion which we have already seen on whiteboard. So I have added extra code here that if this is the first node, that is root is already null, then we'll do this. Then after creating the first node, I should stop the procedure. So I can say return. So here I don't have to write else, because once it has inserted a first node, very first node, then it will stop. Otherwise, if it is not null, then it will enter here. Then it will enter here and insert a new node at a given position. This is perfect. Now next, I will write down a function for performing in-order traversal so that I can confirm the creation of a binary search tree. The in-order traversal of a binary search tree gives sorted order of elements. So let us try this in-order function. I will write down a recursive function. So it will take struct node pointer. Let us call it as P, that is for root node, and here if P means P is not equal to null. Already you know the procedure for in-order traversal, just I am writing it here. Go on P's left child, then printf, print the data, %d, then P's data, then in order P's r child. That's all. I have the functions ready, that is inserting an element and performing in order so that I can see the values that are inserted in binary search tree. Now let us write on the main function and test these insert and in order function. Then later on I will write on search function. From main function I will perform insert operations. I will insert a key 10. This should be a root. Then insert 5. This should go on the left hand side. Then insert 20. It should be on the right hand side. Then insert 8. So it should be on the right hand side of 5. Then insert 30. It should be on the right hand side of 20. Then I will perform in order by passing root of a tree. So when I perform in order, I should get the elements in the sorted order, because in order traversal gives sorted order. Then here also I will give a new line so that I can get a gap. Now let us run this one. If there are any errors, we will remove those errors. Nothing is displayed. So there may be some error in this one. It's not a syntax error, but maybe a logical error. Let us see where I have missed it. So it means it's not displaying in order, means these elements are not inserted properly. So where it could be, even a first value is not displayed. So it means the problem is with the root. So let us check with the root. Root is null, yes. Then when I am creating first node, when root is equal to null, I am inserting a new node with a pointer P. Oh, I missed one thing here. Root should be pointing on this new node P. So even the first node was not created, means the problem was with the root. So here, yes, I missed this one. When root is null and I am creating a new node, then root should point on that new node. Now let us run the program once again. Yes, I got the elements in the sorted order 5, 8, 10, 20 and 30. Perfect. Now one thing I would like to show you, before performing in order traversal, I'll just put a breakpoint here and run the program. Now here you can see in the debug area, root is there. Root is having data as a 10 and the left child and the right child. So if I expand left child is having data 5. And if I expand its left child, then it is having data nothing on the left hand side. Then if I expand the right child of 5, then you can find 8 here. Then let us go on the right child of this root. I'll close this one. This is the right child of root. Right child is 20 and its right child is 30. And 20's left child is null. Nothing is there. So you can see the complete structure that is prepared in the heap. So the tree that I wanted to create is can be seen here. So that's it. We have finished with this insert and in order traversal. I'll remove the breakpoint. Now I will write on a function for search. So the search function we have seen, I will write on that function. So the logic for search is same as what we have used already in insert function, but I will write on search function should return a node in which the key value is found. So this is struct node search for key. Now for searching, I need a pointer that should start from root. So I will take a pointer t that will start from root, and this will be searching for the key. Now the procedure is simple. While t is not equal to null, check if key value is equal to t's data. If it is equal to t data, then return t itself. Else check if key value is less than t's data. Then take t upon left child, t assign t's L child. Else move t upon right child, t assign t's R child. That's it. And if we come out of the loop without any key found, then simply return null. So that's it. This is the search function already we have seen, and this is a iterative version. Now here inside the main function, already I have inserted few elements, then also I am performing in order traversal. Then after this, I will perform search, and search returns a node structure, right? It will return the structure of a node in which the value is found. So I will take a pointer, that is structure pointer, on the top inside the main function. I'll declare it struct node. I'll take a temporary pointer for taking the result from search. Then this temp assign call function search, and I want to search for a key that is 20. After this, I will check if it is returning anything. If it is not equal to null, means the element is found. So simply I will print a message that element %d is found, and from that node I'll take the data, that is temps data, the value that is the node that is returned. From there I will print the data. Otherwise I can print a message that element is not found. Element is not found /n. That's it. I'm searching for a key value 20. Just remember this. I'll run the program and show you. I should get the result, that is element is found, and it should print its data. Yes, element 20 is found. Yes. Then I'll give the number as 2. Let us run and see. 2 is not there in our binary search tree. Element is not found. Yes, here you can see the message element is not found. I mistyped here. So it's a typing mistake. Element is not found. So that's all. The search function and insert function, both the function we have seen, and already I have shown you recursive version of search and recursive version of insert. So you have to do it as student exercise. That's all in this video.